Of all the applications inherited by the team, the one we decided to use for our research was the Beaccon Navigation Master. The Beaccon Navigation Master is an app that will provide a map of the third floor of UTD's ECS building and allow the user to manually configure the location of the Aruba beacons, which will then provide the user a visual of their current estimated location. In order to understand how the beacon would affect the given location of the user, some tests were conducted. With the amount of beacons provided, the distance covered was contained to the lab's hallway and one of its ends. The first test was stacking the beacons in one place, which showed that place as the user's location, regardless of where the user were to stand. If one of many from that stack were to be placed in a different place, the result did not change. As the application software is coded using a trilateration algorithm, the app seeks a triangular placement of beacons and relies on signal strength, therefore making it the optimal choice of placements. In the next phase of testing, how the distance of the beacons affected the location was examined. In order to capture turns properly, the triangle of beacons placed at the end of the hallway was smaller. It was observed that due to this cluster, the application frequently jumped the outputted location to these clusters, even standing from the other end of the hallway. It was concluded that it was important to keep the beacons as equidistant as possible in order to remove this inconsistency. How the signal strengths affected each other and outputted the location, however, could not be determined with the given app. Therefore, a supplementary app was created to quantify the signal strength as the navigation app ran, that also spoke out the Bluetooth device address with the strongest signal every 10 seconds. For the configuration of this app, the beacons are manually placed in the designated locations in the hallway. In the app, the red beacon marker is then placed in the matching location on the map, and a list of beacons is given to choose from to associate the marker with. Once we have configured the beacons, the Bluetooth scanner application runs concurrently, records the signal strength, processing time, and the system time in which the values are recording. Every 10 seconds, the scanner application reads out the MAC address and value of the Bluetooth device with the strongest signal.
5C313FE2E5E closest at -95 dBm.
These values can then be logged and matched to the results given by the Beaccon Navigation Master app to find trends between the data. This may help forward research in smoothing the triangulation algorithm within the software and also better understand how the hardware will affect the results.